thank you for joining with us this morning for what proves to be a very interesting webinar. This is the next in the series of DERlab webinars, and this one is jointly with our colleagues in the PANTERA and ERIGrid 2 projects. It's under the very stimulating title and very pertinent title of Remote Testing and the EIRIE Platform. So I'm sure it will prove to be a very interesting time together. My name is Graham Burt. I'm from the University of Strathclyde, and I'm one of the members of the board of DERlab, and I'm joined today in facilitating this webinar by my colleague Mohammed. Mohammed, do you want to just briefly introduce yourself?
Good morning, everyone. Here's Mohammed Shalvi from DERlab, so I'll be here also supporting Graham with this webinar.
Thank you very much. And if you can move on to the next slide, Mohammed, you'll see, colleagues, the very interesting agenda we have. We'll start with a number of presentations from ERIGrid 2, led by Thomas and the team there, and then on to a contribution from the PANTERA project and question and answer session. So I'm sure if you can stay with us for the full time, that would be great, and I'm sure you'll find it very valuable and very interesting in these times. I trust you and your families are all well, and thank you very much for taking the time to join with us today. And please do make use of the interactive features that will be made available. On the next slide, Mohammed, colleagues, you will see a little introduction to DERlab Network. The DERlab Association is an association of distributed energy laboratories. We total over 30 member institutes from across Europe and the US, with a range of universities and research organizations, national labs, all with a keen interest in the experimental proving of smart grid and DER integration solutions. We work together in this field. There are many shared challenges and many shared opportunities, and the DERlab Association has successfully contributed to the advances that have been made with the integration of distributed energy resources and contributed to the decarbonisation of our grids. I was just sharing last week with colleagues from China that in Scotland we've now achieved 90%. That was at the end of 2019, 90% of our electrical energy demand is now supplied from renewable sources. So significant progress has been made, and that is repeated across many of our states as well. And I'm pleased to say that through the DERlab Association, we've been contributing to that through rigorous testing and through experimentally and validated modelling proven evaluation. Next slide, please, Mohammed. So the association itself is a member association which contributes networking services, such as the webinar this morning, but we also run quite regular internal only webinars for DERlab members, which allows us to share best practice. And we also support a number of international collaborations such as ERA and ETIP. We have a number of joint activities supporting each other on project consortia formation and knowledge transfer, supporting a number of projects with dissemination and some international collaboration. We have a number of information resources available, some of which are for members, but there's also a number of useful databases on the DERlab website, so please do look for those in relation to our research infrastructures, as well as on standards and grid codes. Very informative, so please do make use of those. And also we support our members with visibility of their capabilities, which is obviously a very important part of our role. And the DERlab Association, we work with our members to support each other in improving the take-up of our work and helping stakeholders better understand the value that can be gleaned from experimental and validated model proving. Clearly, with the current restrictions, we are all facing challenges, but remote testing is one way in which we're able to mitigate some of those risks. So this webinar is very pertinent. As I said at the beginning, we're keen to make this as interactive as possible. So Mohammed, do you want to introduce colleagues to the facility for raising questions?
Yes, I would like to introduce. So we're going to collect today's questions and answers through Slido. So if you have your mobile phone, you could use your mobile phone to scan this QR code, and you will be redirected to the Slido room. Or if you would like to use your browser, normal browser from your computer also, or from mobile or tablet, you could go to Slido, and you use the entry code for the room is DERlab. Also, I will going to share in the chat the link so that you could go to the room, and we are kindly asking you all the time to ask questions, so to make it as interactive as possible. As we are expecting to collect a lot of questions, and we have several speakers here in this webinar, I kindly ask you before you write your question to type this to whom you are addressing this question, so that I could address it to the right speaker. Also, if you like a question or you feel that you have the same idea about the question, or you would like to promote this question, please give some up to the question. So by now, I would like to give the floor to Thomas. So Thomas, the floor is yours.
Yes, thank you. Can you give me the presenter rights, please? Yep, already arriving. So I hope that you can see my slides now.
Yes.
Okay, perfect. Then let's start. So first of all, I would thank DERlab and PANTERA and EIRIE Platform very much for this possibility to have this joint webinar together with the ERIGrid 2.0 research infrastructure project. So my name is Thomas Strasser. I'm from the Austrian Institute of Technology, and it's my pleasure to coordinate this European project, which is a successor project of the ERIGrid 1 project, but I came to that later on. During the next few minutes, I'll give you a brief overview about what we're doing in the project, what the project goals are, and then later on, my colleagues from the project are getting deeper into details about remote services, remote testing, and in general, also the lab access program. So the motivation that we had when we worked on the proposal for ERIGrid 2 was we're facing challenges in the planning and the operation of the energy infrastructure. It becomes more complex. I think all of us know that very well. We have the large-scale integration of renewables on the one hand side, so we have challenges and changes on the generation side, but also on the consumer load side. Emerging technologies like battery storage systems, electric vehicle, the whole electric transportation system, heat pumps. So we have more possibilities also to control in some boundaries the loads. Furthermore, we have to deal with the digitalization of the infrastructure. That's emerging trends. We have a deeper involvement of consumers and the market interaction compared to the past. And nowadays also we need, or we are looking at sector coupling, so linking different energy vectors together. The big question is always how to design and validate such a smart energy systems. For sure, we all know we can go to the field and test our developments, but this is quite time consuming and also quite expensive. So in ERIGrid 2, we are trying to work on advanced validation and testing methods. First of all, before I go into the project goals in more detail, I want to give you a very brief overview about the long-term cooperation that we are having here in this consortium and this network. It's a pan-European cooperation where the roots going quite long back. It was maybe not the first project, but it was somehow, I would say, the kickoff of this long-term cooperation in this setting with the DERlab Network of Excellence project. Not to it needs to be distinguished from the DERlab Association, which emerged out of this Framework 6 Network of Excellence program, which was finalized about 10 years ago. Where 12 partners participated in this Network of Excellence with a focus on DER topics and laboratory activities related to that and pre-standardization. Then after that, the DERI Research Infrastructure project has been started. It was at FP7 Research Infrastructure project with around 16 partners, also with a strong focus on DER labs and pre-standardization. But here we had the first time the so-called transnational access. So that means in this funding scheme, we opened our laboratories for external people, get lots of attention on DER topics, which has further been evolution to the or extended to the grid topics in ERIGrid 1. That's a project that we finalized last year. We also enlarged the partners and the possibilities. So we had transnational access, so access to our laboratories and validation possibilities, not only focusing on DER topics, but also on grid topics. And now in ERIGrid 2, we are enlarging this portfolio further with more partners, more countries, but also additional topics. So besides DER topics, grid topics mainly on distribution grids, we also looking at smart energy systems, so the interaction of the electric power system with other energy vectors. Yeah, the key facts of ERIGrid, as you can see here on this slide, so we are 20 partners from 13 different countries. We are sharing 21 smart grid, smart energy systems and DER laboratories. So from these partners, you can check that out on our project website, https://erigrid2.eu. And besides that, besides this physical lab access, so the so-called lab access, or the EC term is transnational access, we are now sharing also virtual facilities. So that's a big change, or I would say a natural extension also in this pandemic times. So that's a new topic which we are going into, and my colleagues will introduce that in much more detail in the following minutes. So overall, the project duration is 4.5 years. So we have started last year in April, and we will finish in 2024 in September, the project. And overall, we are getting around 10 million funding from the European Commission for our activities. As I said, ERIGrid 2 has a big focus on smart energy systems research infrastructures. So we are working on linking the electricity power grid also with other energy vectors like gas network, heat network. Mainly heat network, I would say, in the project is our main focus, but always with this strong backbone, or the electric power grid is a strong backbone. Yeah, and here we're trying to further develop and improve advanced validation and testing methodologies based on simulation, co-simulation, and laboratory testing methods. Yeah. So the goal here is to take the results that we have gained or achieved in the ERIGrid 1 project. That was on the one hand side we call it holistic validation approach, a structured approach for developing test cases and experiment specifications before they are particular or corresponding experiment is implemented in simulation or in a laboratory environment or in a combination hardware-in-the-loop setting. Tools and services for lab interfacing and data exchange. So we are developed those in the previous project in DERI and in ERIGrid 1, quite interesting concepts called Xander, for example, where we had also the possibility to connect different laboratory automation systems together for more comprehensive test setups compared to single site test setups. And here the goal is to further develop these methods and technologies. And besides that, we are also working on training education. So that means to educate young researchers, PhD students, and energy system professionals in our new developments. Also, I think we can consider this webinar as a kind of training educational related event. So in the past, in ERIGrid 1, we had lots of training schools. You can see here some figures or photos from such training schools, workshops, and also webinars. Moreover, also open access laboratory education is in our focus for ERIGrid 2. So I think this is a very brief overview about the project. In the next following minutes, as already introduced by Graham and Mohamed, thank you for that. We are going into more detail related to the ERIGrid topics with the lab access program in general and the virtual services and some examples. So that brings me to the end, and I hand over to the next speaker, which is Emilio Rodriguez from Tecnalia.
Okay, thank you. Thank you very much, Thomas. I guess you are seeing my presentation?
Yes.
Yes.
Could see it.
Okay. Okay, thanks. Thanks very much. Okay, so good morning, everyone. My name is Emilio Rodriguez from Tecnalia in Spain. I'm the manager of the laboratory access in ERIGrid 2.0, and it is a pleasure for me to give a brief overview of this core activity of the project. Okay. Well, as Thomas has mentioned, ERIGrid is not a conventional research project funded by the European Commission, but an infrastructure project. This means that our main goal is to provide access to our facilities to external research groups investigating into smart grids and smart energy systems that have the need of testing of or validating some of the concepts, but don't have the proper equipment, don't have the lab installation for that. So what we do is we open the doors of our labs and also provide technical support during the implementation of the experiments of their projects. And not only that, we use our project dissemination channels to promote the results obtained during these laboratory stays. And everything free of charge. Well, not exactly, well, it's free of charge. It's funded by the European Commission under certain conditions. And this includes also the trips, the accommodation, the subsistence of all the user group members. So it sounds quite good, I would say. Okay, so the user experiments will be implemented in a pan-European infrastructure of 21 laboratories distributed in 13 European countries. All of us using a set of integrated methodologies and procedures. I would like to present you a few photos on some of the laboratories, not all of them, but you can see our lab in Norway or in Austria, also in the UK, also in the Netherlands, in Greece, also in Spain and Netherlands again, just to have some flavor about it. Okay, so who can apply for this? Well, I think that the conditions are not very hard to meet. It must be a research group or an individual coming from a university, a research center, or even from the industry are very much welcome. Located in the European Union or member states, in principle, because we are also allowed to give some access, limited access, 20% of the total access we have to provide to non-EU organizations, so to the rest of the world. But two main conditions must be fulfilled here. One is the so-called transnational characteristics, which basically means that the country of the lab must be different than the country of the user institutions. Please note that here I'm not talking about the nationality of the user group members, but the country of the organizations for which they are working. And the second condition is that they must be able to disseminate the results of the access publicly. That is very important. Let's have a look to the timeline of the process. It's quite, let's say, logical, I would say. It's a sequential process. Basically, we open the call for proposals every 4 months, and we keep it open for 3 months. After the 3 months, we close the call and we start with the evaluation of the received proposal. Normally, this takes 1 month, maybe 1 month and a half. Our aim is 1 month for sure. And after that, when all the proposals are evaluated, we notify the results to the users. For the accepted proposals, they have to implement the projects in the labs within the next six months. Typical duration of the access is around 1 month, is from 3 to 5 weeks, I would say, with a maximum duration of 3 months. It's very well justified. It's not very common at all in ERIGrid to have such a long access in the labs. And when the access finishes, the user group has 2 months for the mandatory reporting about the access, about the experiment results. Okay, so since we are opening calls every 4 months, this means that we have somehow kind of overlapping, not exactly an overlapping, but if we have, for example, the first call, when we finish the evaluation of the proposals received for that call, we are also ready to open the second call. When we are finishing the evaluation of the proposal received for that second call, we are ready to open the third call and so on. So all in all, as you can see, three calls can be open or will be open in a year. Okay, so how to apply? The interested, the potential users must go to our website, basically. So everything is there, the information about the conditions, about the procedures, very important about the descriptions of the laboratories that are involved in this opportunity, the equipment which is available, but also the expertise and the individual conditions that apply for the different labs. Of course, in the website, they can contact the labs for getting further details or clarify any administrative or technical issue. Also very important, in the website, they will find some documentation, which is very, very helpful here, a guide that contains the explanation that I'm giving right now, and also a template for the proposal to be filled. And once this document, this proposal is filled, they have to submit it electronically by means of our proposal submission system, which is based in a tool very well known. It's called ConfTool. They have to go there, they have to create an account, to log in, and they will be ready to upload the PDF document. Okay, so once the proposal is there, so when it comes the evaluation, let's say, step, it is done into a stage that run actually in parallel. One is the so-called pre-screening, where the selected labs by the user perform the first check of the feasibility of the project. Normally, mainly is technical, but also economic feasibility of the project. And also, second stage is the evaluation itself, that is done by an independent selection panel, which is formed by more than 100 international experts coming from the academia and also from the industry. They are able to cover all the fields that are involved in these smart grids, let's say, umbrella, or smart energy systems umbrella. This means that they are able to cope with a power system, but also ICT issues, cybersecurity or automation, of course. Okay, our intention is that each proposal is assessed by 3 to 5 experts, so it's quite well reviewed, I have to say. And the evaluation is based on 4 criteria. One is the general quality and organization of the document, the proposal. Second one is the scientific merit, meaning that we check the relevance or the degree of innovation of the project that is proposed by the users. The third category is about possible extension of the lab capabilities, possible improvement of the know-how or the procedures that are followed by the lab that is going to be involved. And the last one is to assess the degree of compliance with the EU priorities or the EU policies. Okay, so once the proposal has been evaluated, and for those that are accepted, the user group must to contact the assigned lab to agree on the period, to agree on the work plan to be followed. So a contract must be signed to be on the safe side, covering issues like confidentiality, liability, safety, and so on. Also, at the end of the access, it's very important to sign a declaration of use accounting for the number of access days, which is the fundamental unit of measurement of the performance of ERIGrid. So yeah, it's not so complicated. And once the access has finished, it is mandatory. The user group must report on the results. First, they have to fill an online questionnaire for the European Commission. This has nothing to do with the lab. It's something between the user group and the European Commission. And also, which is important, they have to prepare the technical report, with the exception of SMEs, but the requirement does not apply to small and medium enterprises. And the technical report will be made publicly available through our website. Okay. Also, it is important that the user notify ERIGrid about future publications in conferences, in journals where the access results can be further disseminated. Okay, I guess that probably most of the people attending this webinar are thinking that lab access means that the user is physically present, is physically on site in the lab during the experiments. They are right, normally this is the case, but there are another modality, another possibility that is so-called remote lab access, where the user is not in the lab during the project implementation. So the experiments are performed by the host lab staff, and the user, of course, can follow, can supervise somehow the experiments by means of teleconference or a phone call. That is the basic way of doing that, of course. And can maybe, depending on the lab capabilities, can use, for example, a remote SCADA or more sophisticated solution. But that very much depends on the individual lab possibilities. Of course, as you can imagine, this way of getting access has several advantages, mainly for the safety of the users, and of course related to lower expenses that are involved. And as you can imagine, this is a very convenient solution now during this pandemic situation. Okay, for the rest, it's quite similar to the, let's say, conventional physical lab access. So the lab must be prepared in advance for the experiments, a contract must be signed. Of course, the mandatory reporting still applies, and so on. Okay, so certainly, okay, so my last slide, my last slide takes this opportunity to let you know about the calls, about the dates that are involved. The first call closed last December. We received 11 proposals, which is quite good, I would say, considering this COVID-19 situation. We have now our second call open until the end of April, and other calls will come in the future, as I mentioned, every 4 months. So I encourage you to analyze, to consider this opportunity, and please do not miss if you have the need. Okay, so that's all from my side for the moment. So thank you very much.
Thank you, Emilio. And now I would like to leave the floor to Kai to give us his interesting presentation.
Yeah, thank you, Mohamed, and thank you for handing over. So this presentation is supposed to report an experience of remote lab access. Like we performed some remote lab access in the ERIGrid 1 project, but it was not intended. It was really more of an accidental event. So it might be that you take this experience with a grain of salt. If you prepare for remote lab access, you will probably less stumble into it than we did. So first, as a disclaimer, and I think that was said already, but I'd like to visualize it. The virtual access is meant as a service where you basically, as one user, experience certain data, very provided experience. naturally, we do not use virtual reality in that way, but later Steffen will explain how this works in ERIGrid. For the remote access, it's a real lab access project. So you will have a real lab available. You will have a real team that you work with, and I think the close collaboration can also be online. We have all experienced this over the last year, that you can be quite productive also in a remote setting. But you'll also have a real data and you'll have real bugs. So the collaboration is going to be important to be facilitated properly. For this specific experience, we looking at the villas for ERIGrid, lab access project in ERIGrid 1, which was planned as a sort of semi-external internal collaboration. We have TU Delft, that was an ERIGrid partner, DTU, also ERIGrid partner, and RWTH Aachen, at that time not ERIGrid partner. And the idea was to look at geographically distributed hardware in the loop simulation, but also geographically real-time simulation. After some preparation, we decided to split this into two stages, two experiments. Part one was a pure real-time simulation, geographically distributed, and the part two was then looking at geographically distributed power hardware in the loop, where we're looking at DTU facilities being distributed. So that's what we're going to look at later. Geographically distributed power hardware in the loop means, as in a power hardware in the loop, you have a digital real-time simulator, and you have the converter or amplifier and hardware under test. But in between, you have a network setup. So you need some kind of real-time gateway setup, and that's something that has been worked with in ERIGrid 1, but also in parallel, RWTH Aachen had developed this villas node concept. That's what we wanted to try here. Here just geographically, what distribution we had. We have TU Delft, RWTH, and then within Denmark, also we have two different sites. So Riese site and Lyngby site, which both belong to the Power Lab laboratory of the TU. A bit close zoomed in. So we have the Lyngby campus, where the RTDS is sited, and the SysLab on the Riese campus. So there's in straight line distance 30 kilometers, half an hour by car, and 2.5 nanoseconds as a digital coupling. And in this diagram, you can see the setup that we'll look at also in the following slides. We have a network connection. Here's where these 2.5 nanoseconds apply to villas node, which then relays the data over another loop, which relays the data then to control a converter. And then in the laboratory, we have one resistive load and some cables that present the network setup. So this has been an experiment that was aimed at developing something that works remote. So that gives us a little bit of an advantage in that sense, trying out these things. And the access timeline, which is the main purpose here for this presentation, is to understand we had two actually on-site accesses in October and November 19, and then we started with remote access in February. Then the pandemic hit us, and we all had to go home and had a complete remote access. And that was possible. So just to give you a familiarity with who's been involved, Steffen, who will present later, was part of the team, and Maria, both from RWTH Aachen and then from DTU, and Richard from TU Dortmund, TU Delft, were involved. And here also all on site in the SysLab facilities. You might see from the squinting eyes, it was on site, you can get late hours. So what they came up with in this preparation is this setup. So we have a simple network, a distribution network simulated on a real-time simulator, and then we have on the SysLab laboratory being remotely coupled via this converter. The subject of this specific test is that we had a slower converter, so we have a very fast simulation with a high rate here, and then we have a slower interface through this converter, right? And that was kind of the research subject here. How can you make that possible? But also what's important is to realize is, okay, you see the physical access here as in something on the RTDS, something in the laboratory, and the laboratory part can get more complex, the RTDS can be more complex, but we're studying the digital element here of it. So that's here in the top, a lot of communication and a lot of computers. So roughly 5 computers that directly are relevant here as part of the experiments, and interfacing with the lab, you have then one controlling the converter and one controlling the load. In a larger setup, you would probably have more computers in the experiment. But it means you have 3 to 4 controlling PCs that you need to supervise during these experiments. If we now go to the experience perspective, then once we had remote, this was the critical bottleneck. How do we access all these remote control computers? Because the laboratory is already remotely controlled by these PCs. And given that we already had a collaboration before, we had talked a lot on Skype, it was quite natural to go with a Skype and screen share approach to live coordination of the experiments. We were on the physical side, the DTU folks were still sitting in one room in Riese, so on the SysLab, close to the SysLab laboratory. So the experience is usually in SysLab that you have some remote control, but you're on site to be able to fix things. So then when the pandemic hit us, we all had to go home, and we were questioning, was it possible to even continue the laboratory experiment? We were just missing a little bit to be able to complete this. We tried and it worked out. So we managed to get the right IT setup with the help of our IT departments and our to get a safe setup where we could each from home. I plotted 2 locations, so everyone was really fully remote accessing the lab, and we only had 1 lab technician on site. So this is more remote than you'll need probably, but it's been possible to go that far remote, and that's mainly the story here. I don't want to spend much time on our experiment results. You can look them up. It was a very interesting work, which is also about remote testing. But I will not go into the results here now. For those that would like to look at the results, you can also look at the diagram below. From the remote lab access experience, I would like to highlight that we had a 2-step on-site preparation, and then we could go over to an online collaboration. And we had a team working already. So the frame for the online collaboration was quite straightforward. We had a fixed experiment protocol that we were following. We knew where our data was going, etc., etc. And it was extremely helpful to have the lab automation, as also Steffen highlights here. I think the benefits that you get from this remote part of the lab access is mainly 2 things. You can reduce the travel time, and you can be more flexible. So that means you have more or less pressure on having everything fixed on site, and then sort of be able to iterate a little more. What we haven't tried is the reverse situation to start remote, but I'm not entirely worried that it's impossible. You just have to keep in mind that it's like any online collaboration with a complex subject. You need to fix the frame properly. So this is, as my last slide, I would just want to compare what we have experienced here in ERIGrid 1. Was one of 2 experiments that were using online collaboration with remote access. So we had a Villas for ERIGrid that I just presented, and then there was the H2 AI project, which the University of Strathclyde, where there was also 3 remote access days. So in summa, I would say remote access is possible in principle. It's clearly different from virtual access, so no need to confuse that further. And then we can see this as an efficient alternative to doing something completely on site, but it's probably best combined if that's a possibility. And I think it can be used both in preparation, but certainly, as we've shown, for follow-up of previous visits. So I would like to thank you for your attention, and then hand over to the next speaker, who is Steffen Vogel. Thank you.
Thank you, Kai.
Okay, hello everybody. My name is Steffen Vogel. I'm a research associate at RWTH Aachen under the team of Professor Monti. We as RWTH Aachen, we are a new participant in ERIGrid. So in the first iteration of the project, we're not a member of the consortium. We only participated in the Villas for ERIGrid exchange. So now that we are within ERIGrid, I have here the role of the work package leader for the virtual access work package, which I want to present here in the next 10 minutes. I will start with a brief definition of what virtual access actually is and how it is different from the remote access. Then I will cover the specific of how we implement virtual access within the ERIGrid project. I will show you how to actually access and use our facilities yourself. And I will give a brief overview of which facilities we provide. And after this presentation, we will then actually have two small demonstrations of two of the facilities. So what is virtual access actually? Virtual access ensures free of charge access to electronic infrastructure. This could be, for example, some sophisticated computer services, some computing power. So for example, a high performance computer, special networks, databases, and data banks of data which you could use. So it's usually either some sort of data which is provided as data as a service, or some computing facility where you can, for example, perform some simulations as a service. Virtual access is a nice tool which allows you to participate in such a virtual research community, because in some of the tools, it allows you to collaborate with other partners, to use the tool as a collaboration platform. And it's also nice to see that the virtual access as is not just a tool which we see in our community, in energy research, but also in a lot of other fields, where each of the fields implements virtual access in a little different way, which we will see in a second. But it's important to not confuse virtual access with remote access, because remote access usually means that we have some sort of physical lab or physical lab infrastructure. That could be, for example, a real-time simulator or some lab equipment. For such physical infrastructures, you usually need to somehow allocate the usage or reserve the usage of this equipment. And this is something which has to be done manually. So you need to coordinate with the users on site, whether they need access to their own lab equipment or not. In contrast, virtual access is a scheme where we don't have this limitation. So the goal of virtual access is that you can access this facility anytime without any restriction, without any prior coordination. And that means that in contrast to the transnational access scheme, virtual access does not require any application. So you don't need to apply for using our facilities here. There are no proposals which should be or must be submitted, and there's no selection process which will select you as a user who can access the facility. That means everybody can open and log into our facilities right away. You could do it at this minute, and you can start using the facilities or just checking yourself whether you like them, whether you could use them for your research. This access is usually done through communication networks. So everything you need is just basically, in most cases, a web browser and the right entry point where you can access the services. And that's basically possible by eliminating most of the administrative obstacles. And yeah, once you use virtual access, you're really not obliged to any sort of reporting. You are not required to publish your results. You're not required to write a paper about it or report to us back at all. You could do it, and we never really noticed that you used our services, and that's totally fine. In contrast to the transnational access, and as a consequence of making it so simple, we cannot provide direct individual support on site. So you cannot expect to call us or have a chat session where we help and support you right away, because that would be too much effort on our side to implement this. But we have an alternative way of supporting users of our virtual access facilities. Yeah, as said before, virtual access is a novelty in ERIGrid 2.1. We didn't have it in ERIGrid 1. Virtual access in ERIGrid 2 is provided by 8 partners, which provide access to 9 facilities in total. And the virtual access is offered during the complete project lifetime. So we started last April, and we had the first virtual access facilities online roughly last September, with more coming now online one at a time. And they will stay online until the project end, which is in September 24. And also a nice side effect which we see is that most of the virtual access facilities are built using open source software solutions. So it's not that these facilities provide you access to some closed source MATLAB or closed source simulation tools, which you cannot install yourself or where you possibly need a license to actually use them. Pretty much everything we do in these virtual access facilities is based on open source tools. And the virtual access work package in ERIGrid is also interweaved with other project activities. So we have the joint research activities where we intend to continue the development to improve the virtual access facilities with the feedback we receive from our users. And we have the network activities where we plan to incorporate the virtual access facilities into, for example, webinars or video tutorials which demonstrate how to use them. So in order to access virtual access facilities, we have multiple steps, but they are really fairly easy to go through. Usually you start with the ERIGrid website, where we have a dedicated page listing all of the facilities. There you find a short description. You can select the one which you are interested in. After that, you will be forwarded to a short questionnaire, which is really only asking you to fill in, I think, five input fields, like your affiliation, where you come from, how you plan to attend the facilities, and so on. After completing this questionnaire, you will be directly forwarded to the partner site, to the facility itself, where you can start using the facility. In addition to that, we have established a discussion forum, which we plan to use as the main way of supporting our users. The discussion forum is a pretty standard web forum, so the users can register there, they can ask questions, and all the partners who provide the access are there as well. They will be notified about new questions, and you can exchange your experience there as well. So the big idea here is that using this forum, we have also a way of establishing a knowledge base. We can document the questions which have been asked before, and new users can easily get up to speed. This is the website we see, the ERIGrid website, where we see the selection of virtual access facilities. And you can click on any of them. After that, you will be, after a short description, you will be forwarded to this questionnaire. So you see we only have actually 4 fields which you have to answer. This is completely voluntary, but we mainly need it for reporting to the European Commission. Also, a new addition is that some of these facilities, as well as the discussion forum itself, are all integrated into a project-wide single sign-on. So you actually only need a single login account, which then allows you to access all of these services. Or no, not all of them, but we have now 2 facilities participating, as well as the forum itself. Yeah, and here you can see a screenshot of the forum. And now I will start briefly going over the different facilities which we provide. So the first one is from RSE. It's a cloud database platform providing you access to historical and real-time data of a low-voltage microgrid. And it's implemented using a time series database and using Grafana as a front end. And that allows you to go through, I think, up to a bit more than a year of data they have now inside of their own microgrid. In addition, there's also an object storage providing you with topology assets and some test case descriptions. And here we see a little picture illustrating the microgrid at RSE, in the distributed energy resource testing facility. And for some of these components here, you will then have access to this historic and real-time data. The next facility is from AIT. It's called the Smartest Sim Lab. It's a simulation as a service platform built on Mosaic and Jupyter. So from Mosaic, there's a Jupyter extension which allows you to build your own Mosaic simulation and scenarios and then execute them completely over the Jupyter platform. And the Smartest Sim Lab is also integrated into the single sign-on service, which I presented before. And here we see a little screenshot of this facility. So for those who are not familiar with Jupyter, and we will see it later as well, it's a completely web-based tool, which basically gives you a complete development environment. So you can have these multiple tabs here. You can write your own code. We have some controls to start and stop the simulation. So it's very, in some sort, it's similar to some of the desktop tools you use for your simulations already. But this brings everything into the cloud. So we have everything running on the servers of AIT itself. And you as a user basically only need your web browser and nothing else. But of course, these tools allow you also to provide your own data, your own grid models, your own time series data, which you then can use and feed into these simulations. And later on, you also have the chance to extract the results there and use them for your own dissemination. The next facility is from ICSCS and TUA. It's called Virtual Lab. It's mainly an educational simulation tool. They provide 2 experiments where the students can adjust a few values, and they have a simulation running in the background and providing the students with some real-time simulation dashboards. I have some 2 screenshots here. This is the first experiment where they have a scenario of a simple voltage control with a PV inverter. Students can adjust the reactive power control as well as provide an active power set point, and they will see basically how the voltage reacts on when adjusting these values. The second experiment is a small microgrid where they can adjust one of the loads in the microgrid and then see how the other components in the grid react to that. And it's also important to note that these two virtual labs, they're modeled according to the physical lab which NTNUA has on site. So it's a nice way of them for the students to approach the lab, to first learn how it's structured, and then maybe later on starting your thesis at the lab and using the equipment themselves. The next facility is from University of Strathclyde. It's the Smart Grid Monitoring and Visualization Platform. It's provided by the Dynamic Power Systems Laboratory. And it's mainly built around two phasor measurement units, which are deployed in the British grid. So there's one in the University of Strathclyde and another one in their Power Networks Demonstration Center. And from these two PMUs, they provide you a near real-time and historical access to the grid frequency, the row curve, as well as some voltage phasor diagrams, and also historical composition of the generation in the British grid. I also have some screenshots for that. So here we see the generation mix in Great Britain and how it's evolved historically. And here we see the live data from the grid with a grid frequency and phasor diagrams. So the last two facilities, which I will quickly touch here, will also be presented as a live demo in the next two sessions. The first one is also from ICCS NTNUA. It's a tool for designing small-scale wind turbine generators. And it's composed of several sub-tools, and some of them are using finite element method magnetics. So this is an open source tool for doing simulation of magnetic effects. And they also have a quite interesting tool for doing for using particle swarm optimization to actually then optimize some of the parameters for constructing a generator. But I think I'm sure this will be also demonstrated later. And last, we have the VLab from RWTH. That's our facility. It's also based on Jupyter, very similar to the infrastructure from AIT. But in contrast, we don't combine it with Mosaic, but instead we have our own simulation tool. It's called DPSim. It allows us to perform EMT, electromagnetic transient, load flow, and dynamic phasor simulations completely from within the Python and Jupyter Lab framework. You can define your grid models either in Python or C++ code. So you could script any tool which constructs your grid model, or you could read in the grid model from common information model files. And the nice side effect of having everything in Python is that you can completely define such a simulation from the modeling to scenario definition, so what you actually want to simulate. So you can parameterize the simulation. You can then execute it either once or multiple scenarios at the same time, and then later on do the complete post-processing analysis of your results also in Python. So, and that allows you to have basically all the complete workflow in one tool. And we are currently working on also a tool which allows us to extend Jupyter with a tool we call VillasWeb, which then gives us also some live and real-time dashboards. So we can actually perform real-time simulations there as well, and then provide the user a near instant feedback on the current simulation state. Yeah, this brings me to the end of this first session. I presented or gave a quick overview of 6 of the 9 virtual access facilities. We have 3 more which are in the pipeline, and we expect them to go online this year. And then for the future, because I only could very briefly touch most of the facilities, we plan to have more in-depth webinars and workshops focusing on the individual facilities and giving you some more in-depth details and examples how to use them. Okay, that's everything I have for the first presentation about the ERIGrid virtual access facilities. I will now switch to the next presentation and give you a little demo of our virtual access facility at RWTH. And we call it Virtual Lab. It's a web-based simulation platform, so you can use it for simulation as a service. You can bring your own model and data files into the platform. And of course, you can take away your simulation results and then publish later in a journal if you want to. The Virtual Lab is composed of two components. So it's largely built around Jupyter Lab and Jupyter Hub, which provide you this interactive computing environment in your web browser, and I will show it in a second. And the second main component is this DPSim simulator, which is itself implemented in C++ and basically developed by us also as open source software. All of that is running on our own Kubernetes cloud. So we have a small on-premises cloud, which runs at RWTH, built out of around 10 servers. So we have plenty of computing power to also perform some longer or more complex simulations there. And the nice thing is that due to this Kubernetes cloud, even multiple users which use our service at the same time get distributed across these 10 machines. And we don't have any problems in regards to scalability. And also one important point is really from the ground up, the full stack of the software which we use to build VLab is open source. And that really starts from the operating system, basically Linux, then to the cloud system, Kubernetes, Jupyter, DPSim, all of that is open source. And I will have a link on the last slide where you can actually see the source code. And that's very important to us, because as researchers, we want to give you basically a full insight how each of the simulation models is implemented, each of the components, and also provide you with the possibility to extend it for your own research. So we are very open here, and we really encourage you also to contribute there. So if you have any new developments, any new models, we are very welcome for your submissions there, and we will want to incorporate that. Also, maybe interesting to note that since a few months, we are now a partner of the Linux Foundation, so the industry organization which accelerates and supports the development of Linux and many other open source projects. And the Linux Foundation has a new sub-project which is called LF Energy, in which we now basically are contributing DPSim and a few of our other open source tools to continue the development of these open source solvers and tools under a broader community. Okay, quickly, a few words about Jupyter. It's this web-based interactive development environment. It allows you to document your code and research in something called Jupyter Notebooks, which combines basically code, data, and your annotations. You can write some comments, you can include LaTeX formulas, and so on. And it's highly extensible, has a user interface. We see this, that the Mosaic simulation tool has a good extension, extending Jupyter with additional controls and editors for editing a Mosaic scenario. And beside Python, it supports many other programming languages, such as Octave, Julia, R, C++, and so on. And Jupyter, I think many of you maybe are already familiar with that. It's a tool which is used quite widely in the research and educational community. So we have many universities which are already basing their courses on Jupyter, provide maybe instead of a PDF script, they provide the lecture materials now in form of Jupyter notebooks. In order to make Jupyter notebooks accessible to a bigger group of users, we use a Jupyter Hub, which is a multi-user tool for managing multiple users and running this basically on premises on a cloud system. And the nice thing is it provides you with persistent home directories. So every user who logs in gets their own little space of where they can store files and results before coming back later, maybe a week or a month later, to pick up your work and have the same state. And it allows us to have the scalable deployment in Kubernetes, where we can really scale up to thousands of users at the same time. And also this integration into a single sign-on service. And here you see a little screenshot of the tool, which, if you look at this in more detail, pretty much looks like a development environment. So if you're familiar with Visual Studio or Eclipse, for example, these development tools, or RTLab from OpenRT, for example, they look pretty much the same, with the big difference that you don't need to install anything on your local machine, and you can get started right away. And that's a very big plus if we want to use these tools in the education and teaching. Because for many students, it's a big obstacle to install, let's say, a 5 GB MATLAB install or something like this. So we see that in our courses where we use these tools, we can, by using Jupyter, we can enable much more students actually using and trying out these simulations on their own behalf, which they wouldn't have done before because they would require to install some big tools. A few words about DPSim. It's completely in-house developed at RWTH. It's a modified nodal analysis solver implemented in C++. As in the name suggests, it started as a solver for dynamic phasors, where we basically simulate kind of the baseband signal instead of the instantaneous 50 Hertz signal we usually have. But nowadays, it also supports load flow simulations as well as the EMT style simulations. Because C++ is hard for some, we added the Python interface to it, so you can use most of the features also from within Python. It can read in common information model files and has the interface to Villas for providing interfaces to external tools. So we basically have a clear separation. DPSim is a simulation kernel. It does a simulation, and all the interfaces, I/O to external parts, is handled by our Villas node gateway. It also performs real-time as well as offline execution. But there we have to be a bit careful. We mainly use the real-time features if we perform dynamic phasor simulations, because performing real-time simulations for the EMT style simulations can become tricky due to the time steps. And it's also open source. And now I can quickly jump to our live demo. And I hope that all of that will work. I basically start by accessing the ERIGrid website. If we go to the lab access section here, we will see the list of all virtual access facilities, as I showed in my previous presentation. I will select the RWTH. Description here, we get a short description and the button to access the facility. Then we get this little user questionnaire, which I fill out. And then I get immediately directed to our VLab. Here I am now asked to log in again, and I'm using the single sign-on server, which I mentioned also earlier. And this brings me to my Jupyter environment now. It's a pretty powerful tool, because here you can write any Python code. You can even get your own terminal where you can run your code and so on. But I will quickly start because we don't have that much time to show you a brief example of such a DPSim simulation. So you see here one of these notebooks where we basically can interleave any documentation, formulas, even images and videos could be included here with some Python code. And this Python code can now be executed, and users can also modify and edit this Python code. So we have a few examples provided here. And in the next cell, we see how we can basically build up a very simple grid topology. So I define a few nodes within my grid, have a ground node and then 3 others, and a few components like a voltage source, a resistor, inductor, and so on. I can parameterize each of them all in my Python code. And last but not least, I can connect the individual components to my previously defined nodes. And then define a system topology where I say I have these simulation nodes and have these components. After doing that, basically the tool will construct a system matrix, and then I can also have a small graph-like visualization of my topology before then performing the simulation with a modified analysis solver. And we see I can adjust the time step, simulation duration, and so on. I have a logger, which allows me to select a few values of interest or signals of interest, which are then logged to a CSV file. And last but not least, I can plot my results here, for example. If we look, we have this log directory, which gives us then like a couple of log files. We can look basically at the CSV file, look at the results, or do any post-processing as I have done here in Python directly. So as my time runs out, I will just quickly go through a more complex example, which we also have here. This is a WSCC 9-bus system. I will quickly execute it. This is reading the grid topology actually from a ZIM file. So we have a bunch of XML files. And then I can also get this graphical representation again of the grid topology, which looks a little bit different from the typical 9-bus topology you might be familiar with, but that's just because we are using Graphless here to do the rendering. I then go ahead and I modify the grid topology, which we have seen loaded from the SIM file by adding a PQ load, which we then now also see here. And this PQ load now gets changed. The load set point gets changed during the simulation. So we add an event here at 0.2 seconds into the simulation. We close the breaker, and thereby we can introduce some transient into our model. The simulation is now running here. And then I will quickly go through the analysis. I can look at the voltage waveforms, which we see after the transient. Okay, there are a few more examples, little and more complex, but the big point here is that you have the full ability of modifying and define your own scenarios. This brings me to my last slide, which is a little outlook how we plan to continue the development of the DERlab. We have another project going on internally at RWTH, which is called SLU, or Second Life for Energiewende. And I'm not sure if everybody knows the game Second Life. It's a virtual reality game from Linden Labs. You see a little picture here. Provides you a virtual reality to walk around, and you can implement some sorts of virtual experiences here. And the idea was that we built a simulation tool, not exactly using the Second Life game, but have an experience for students which is very similar to it. And to do that, we extend the Jupyter environment. We add our Villas web tool. which is a tool which allows us to manage simulation scenarios. So we can have multiple models, we can have multiple simulators, and the Villas Web tool is managing all of that. So we can assign a model to a simulator, we can execute the simulation then, and we basically also have a database of past simulations and their results. So it's kind of a logbook for ourselves as well. And the nice thing, if we do these simulations in Villas Web, we are performing basically real-time simulations. So users can have a real-time dashboard to actually see the effects of, for example, adjusting a slider in the dashboard of a load and then see how this will affect the simulation. Okay, that's all from my side. Here are the few links. You can also find them later on in the deck set, which Thomas will publish. And thank you very much for your attention.
Thank you. So going to the next presentation, Kostas. So I would like to give you the floor.
Thank you very much. Okay, you can see my screen, yeah?
Yes.
Okay, thank you very much, Stefan, for the introduction. I will be presenting you the online tools of the ICCS and TUA called Open AFPM tools. These tools have been developed. These tools have been developed in the SmartRU research group led by Professor Nikos Hatziargiriou, and its dedicated sub-research group on rural electrification, the rural electrification research group. And they have been developed in collaboration and for the use of the Wind Empowerment Network, which is a global network of practitioners, researchers, and manufacturers of locally manufactured small wind turbines, with about 70 members in 30 countries, and most of them performing rural electrification activities on the field. So the main idea of the tool was, apart from its educational benefits for university students, was to assist practitioners on the field in order to be able to modify standard open source wind turbine designs with the materials that they could find locally in the market. So the Open AFPM tool essentially is a simulation tool for the axial flux permanent magnet generator of a small wind turbine. And it uses the open source finite element analysis software FEM, which is a very powerful and open source tool for performing magnetic analysis of generators and other problems. And as you can see here, it is a part of the generator that we are modeling and then doing different kinds of designs. So the toolset consists of 3 tools. Magn AFPM, which is the more, let's say, practitioner focused or dedicated tool. This is a tool where the user can input the magnet dimensions that are available to him or her, and the specific design of the generator required for a specific set of rotor blades will be calculated and presented for the user. Then the user AFPM tool essentially performs a complete analysis of this generator using FEM, the simulation software, as it would have been done in a test bench. So the user is able to rotate the generator at specific rotational speeds, and apply different currents. So this is the part that could be validated experimentally in the NTUA labs, which have been some of the transnational access projects that we've done in previous years and editions of this program. Finally, the OptAFPM tool is more research, let's say, or more commercial or manufacturer centered, and it allows for optimizing the magnet dimensions of different generators and using a particle swarm optimization and taking into account aspects such as generator efficiency, cost, and mass. But we will have a look at that during the demo in a bit more detail. In addition to these tools, there is let's say a design library. It's called Design Tips, where the tools are explained and a general process of how to use them and what's the background for these tools is presented. And finally, there is an interactive, there is a map of where users are located in order to get the feel of the global community using them. So now we will have a look at the tools themselves. This online, the online version, the online interface for the tools has been funded by Visions from the Wuppertal Institute in Germany. And it was part of a knowledge exchange project which we conducted in Nepal with local partners, and it also included an electrification project. So now I will go to the tool. So once you log into the tool, this is your landing page. You can go to the design tips and read through in order to get an overview. There's a discussion forum where you can ask questions and you can see the user locations as we have described. So you could go to new simulation and you can pick one of the three tools. So the first tool to use is Magnet AFPM, which will give you a first overview. So when entering the tool, you'll be asked to give a title and for this specific simulation, and then various inputs that have to do with the specific wind turbine that we are designing. So that will be its turbine radius, the efficiency of the blades, cut-in and nominal wind speed, the tip speed ratio at cut-in, and different other parameters such as the shape of the coils used in the generator, so rectangular, keyhole, or triangular, fill factor of the coils, stator thickness, and then there are also different generator topologies that can be simulated, such as a double rotor or a single rotor, for example. There can be different magnetic materials used in the simulation. The number of poles can be varied, and here are the magnet dimensions which can be specified by the user. And the rotor disc thickness. So these are the main generator input variables. Then there are some system inputs. So usually these wind turbines are used in off-grid systems with battery-based systems. So this will be the battery voltage, the nominal voltage of the charge controller, some transmission losses, rectifier losses, so on and so forth, and then some costs for different materials in order to get an estimate of the total cost of the generator. So by clicking save, the simulation will start running. So then you enter here the main let's say list of simulations. So you will be able to see here your simulation, and it will be in progress, and there will be a countdown to how much time it will take. So this is what the result of Magnum AFPM would look like. This is the actual part of the generator that has been simulated in FEM with the two rotors and the coils in the middle. There are different kinds of results. For example, let's have a look at. So these are results for the rotor. So, for example, you would have what is the outer radius of the disk. So it will define the actual size of the generator. Other simulations, like if the back iron disk of the generator is saturated or not, depending on the thickness entered, flux density in the air gap, so on and so forth. Then there are stator outputs, which is the complete design of the stator. So, for example, how many turns per coil, what wire size. So for each one of these, there is also this black text box, which gives a further explanation of what this output is. For example, the heat coefficient, the current density of the generator, and many other outputs such as generator power and basically what actually goes into the batteries. So this is the power after the rectifier going into the batteries. And finally, there's also some costs calculated. So this is the total cost of this generator based on the input values of material costs that were given by the user. Also, there are quite a lot of graphs that one can access. For example, this is the torque versus current graph of this generator. So these are the different current steps that have been defined for the simulation. For example, the EMF versus speed graph of the generator, and many others, including, for example, and the aspects of the magnetic field, and so on and so forth. So if the user wants to do a more in-depth simulation of this generator, then the user would ask the tool to perform a user AFPM simulation on the same generator, and this time we would have a simulation where the actual rotor is rotated in the simulation for different RPM, for different revolutions per minute, and for different currents. So this would be a more precise result when compared to Magnum AFPM. And finally, we will have a look at OPT AFPM. So basically, let me just go to the new simulation. So here, the optimal dimensions of the generator magnets could be simulated while trying to optimize efficiency, cost, and mass with different weightings. That's also a possibility, and with different design variables. So this would be the magnet length, the magnet width, magnet thickness, and also the stator thickness. So the user needs to define how many particle generations, how many times to repeat the optimization, and a set of maximum and minimum values for the different design variables, and some general inputs for the rotor. And the results of this would actually show how each one of the design variables goes to a single value and converges to a result for the 4 different design variables, and also giving an estimate of the objective function and its parameters. So thank you very much. This has been an overview of the tools of OpenAFPM.
Okay.
And yeah, if you have any questions, you are free to ask in the forums. Thank you very much.
Thank you, Kostas. Maybe we could give 3 minutes as a break for our audience and just to grab a cup of water. And in the meantime, I will give the presentation right to Venizelos. And please, we will be back at 11:05 Central European Time. Okay, Venizelos, I guess we could start now. It's 11:05.
Okay, thank you very much, Mohammed, and thank you all for connecting. And I'm also very much thankful of all our colleagues from ERIGrid who have presented us of the capabilities of the project, which are so helpful to research and innovation community of Europe. And we, as a project PANTERA, we are putting forward our vision for generating a platform, the EIRIE platform, that is much more than just reliable information to support the energy transition and the research activities in Europe. So we would like to just mention that we are a project financed by the Commission to help research and innovation in the low activity countries of Europe, There are more than 15 countries in Europe that are not contributing enough in the research and innovation for achieving the objectives of the energy transition 2030 and 2050 targets of Europe. And we, as a platform, we are trying to find ways of helping this. And we, as a PANTERA project, we have put in a process through which we aim to bring together activities in Europe that will generate this EIRIE platform, as we call it, the European Interconnection for Research, Innovation and Entrepreneurship, the platform that is going to be hosted on the JRC Europa Smart Solutions services area. And this is what is going to give it sustainability as to continue serving the research and innovation community of Europe after the end of the project. We are working until the end of 2022, through which period we are trying to develop as much as we can in support of the research and innovation community of Europe. But afterwards, a service contract supported by DG Energy is going to take over in order to continue this visionary work that we put together through the PANTERA project, aiming to serve the communities forward. And we have put together a recap process, as we call it, a research and innovation status and continuous gap analysis for providing solutions to the research and innovation community, both in giving information, but not only that. We intend to give access through this platform the tools and means to facilitate the work forward and host activities like what you have seen through ERIGrid, but also through other projects to help us to enrich and make a single point of connection for the whole of Europe. So this process that we are putting together is bringing a lot of the activities that are now happening within Europe and trying to bring together ways and means of developing a process that will continuously enrich the EIRIE platform for the years ahead and give facilities and information and data and knowledge for the research and innovation community to act through that and solve and help their research and innovation activities that are lacking within their own country or within their own environment. And so this process is going to be a continuous way forward. We are working through ETIPSNet, the European Technology and Innovation Platform for Smart Networks for Energy Transition. We are working with the working groups and experts supporting that, together with our experts within the PANTERA consortium. We are working through working teams to develop all that is, not all, but substantial things that are required, and we consider at this point in time very important for the research and innovation community in Europe, like research infrastructure that we have been listening this morning through ERIGrid activities, and continue that into forward with the next steps of how we can make this research infrastructure in Europe accessible through the EIRIE platform to the whole of Europe and on a sustainable way, because as you heard, ERIGrid has a period that through that they will continue their excellent work that they are doing, or we are doing, because we are partners in this. We as FOSAM in Cyprus, we are partners in this consortium, and continue the work forward for next generations to come and continuously receiving the services that will be generated. In addition, we are working on building regulations and standardization and make it accessible as a means of where we are with standards today and where we are with codes today as far as our research and innovation work, and what is missing, what is lacking, where are the shortcomings, and how we can build the way forward. So also we are doing a lot of work in research and innovation mapping and how we can evaluate the progress made and how we can build the process in order to achieve this forward. So how can we make this work and function and operate in order to give to the research and innovation community the means for achieving this? And also through these working teams, we are keeping alert of what is happening elsewhere in the world in order to make sure that we support the research innovation work in Europe, taking into consideration what is happening elsewhere. So we are building trustful cooperation with stakeholders. We have put a process forward of how we can achieve that. And this is part of the work within the PANTERA project to make sure that we have all that is required to build partnerships, to enrich dialogue, to benefit from consultation and communication in order to achieve our objectives. And of course, the EIRIE platform is not anything that will go on this platform. We would like to put the process forward through which what is coming through, we will blend it in a way that will be made useful for the research and innovation community in Europe to use. And also we are going to constantly enriching the platform, bringing new solutions, new tools, new data information knowledge in order to facilitate the research and innovation work in Europe. And we would like to build on the strengths of projects like ERIGrid that we have seen now, and we would like to say that what is happening within ERIGrid is what we envision to have as accessible to all research and innovation community in Europe. As already said by ERIGrid, this is open to all Europe to use the infrastructure to help the research and innovation, but is limited. Is limited, let's say, for the period that the project is happening, or is limited to the calls that are happening within the year. Our vision is to extend ERIGrid 2 to ERIGrid 3, and through which we would like to facilitate a process through which there is not going to be any limit in conducting your research, provided that there is such capabilities within Europe, anywhere where they are, and convince the Commission to take this as a responsibility forward in enriching solutions and giving access to the research and innovation community in Europe to use this infrastructure to facilitate their work. In addition, we are building good collaboration with other projects like EDI, like ASSET, through which we would like to facilitate anything that is becoming virtually accessible throughout Europe, which helps educating people, training people, and having means. And we have heard a lot today from what is already happening within the virtual research services that are being built around Europe, both in design, analytical, but also knowledge. We would like to build on that and make it easily accessible through the platform that we are putting together and have it available at the fingertips of the research and innovation community of Europe in order to help the process. And we would like to do that and building tools and methods and solutions. And we are doing that within the ETIPSnet Working Group 5, through which we are facilitating this. And we are working together with ETIPSnet, together with Bridge experts, in supporting this process forward. As I said before, this is going to be a sustainable process because this is going to be taken as a responsibility forward by the service contract that DG Energy is putting forward in order to support and take over and continue this vision forward in support of the research and innovation community in Europe. And our vision, our ERIE platform, is already putting together all that I'm describing into real a system that is going to go live beginning of April, and starting building this and making it available and facilitating this process, and gradually continue and reach and serve and offer solutions and means to research and innovation community in Europe. And as you can see here, we have put together a lot of effort in order to make it as rich as possible and as inclusive as possible, and as accessible as possible, to have this open to all research and innovation community. But for the moment, we are talking about smart grids, but it's not going to be limited to that. We are doing an architecture through which it can be expanded to all the energy vectors that are required to complete the energy transition. We are a project of limited time, but as I said, we are putting together a process through which it's going to be sustainable and it's going to be enriched and continuously grow in the years ahead, provided that there is this need appearing and taking up as a need and put forward as a solution for supporting the process. And we would like to indicate that the architecture that we are putting together is going to be constantly growing in data, in information, in knowledge, and make this as a single point of connection throughout Europe. And wherever it is this data, information, and knowledge, we are putting the architecture together, we are putting the means and the solutions together in order to have this accessible through the single point of connection, the ERIE platform. This doesn't mean that the ERIE platform will host every bit of information in Europe on its servers, but it will have, if that cannot be made possible, it will have access, and it will lead the research and innovation person who is interested to see what is where, to be able to access it through the ERIE platform. And so for this reason, we are putting a quite advanced features of the ERIE data model definition, through which we can manage all that, and we can give the way of putting it in the repository of this platform to be made accessible, to be correctly arranged in order to be easily accessible by whoever would like to use it. And we have made and we have advanced a repository through which it has a strong search tool through which it can find and can check and it can give back all that is required by the person looking for it. And so the ERIE platform contains a layout for the search tool. It is composed of the following components: the area of selection, projects, organizations, data collections, a quick access to important areas where people are interested in, and advanced search forms for each category, faceted searches, and paginated lists. This is going to be available as from April forward, and we can inform you that we are safely connecting platforms throughout Europe. And we have built solutions, we have built applications through which they are making this possible. And we can connect through this for the access to the Drupal data from other systems. Drupal is again an open source capability that is offering this web service application to be functioning. And this technology permits access from practically every language and services. It becomes a bridge between different platforms and applications. And Drupal 9, which is the current version of the application, has a way to expose endpoints to manage the Drupal content types, and hence accessible to all that is visiting the EIRIE platform. We are currently working with a number of platforms in Europe, and we are constantly discussing with others to bring them on board and have this accessibility. And we are trying to do that through a passport approach, shall we say, through which we make sure that whatever is coming on EIRIE platform is well documented, is well protected, and we have the right for this information to have access to. So that's why we are putting together a process through which it will be continuously managed and making sure that what you receive through the platform is a reliable source of information, but at the same time, we are not violating any of the data protection principles that exist in Europe. So the process, as we said, is ongoing. We are moving forward with making it available to all, and we are promising that April will be the month through which you will have full access to this, but not everything. As we said, this is going to grow over the next years, and it will continuously grow in a direction that can serve you and all the research and innovation community in Europe in the best possible way. Thank you very much for listening, and thank you for being part of this interesting webinar of today. Back to you, Mohammed.
Thank you all, and thanks for all the participants, and thanks for the speakers. I would like to take this opportunity to share my screen and share the questions that we received from Slido, and I will kindly ask the speakers to answer those questions. So the first question came in, I guess is related to the PANTERA platform. How will the mentioned established platforms be integrated, for example, via an interface, or will be elements be actually transferred to EIRIE?
Yeah, if I can say, I have already mentioned that, but the intention is to have on the EIRIE platform anything that we are given access to and being allowed to transfer it. But if we are not allowed to transfer it, then we will have agreements in place through which the content will be accessed on the server and within the law regulations of the specific association, of the specific entity that has the right to that information. And if any information is not publicly available because it has restrictions by the owners of the data, information, or knowledge, then the summary of that, or what the content is all about, will be made available so that a person interested will have all that is required and where it is, in order to make sure that if it's a must to have, then to access the right person, the right entity, the right association to get more information about it.
Thank you, Venizelos. Going to the next question is to ERIGrid. Do you see an evolution of virtual access and remote access that can be met as a potential of more labs as a service, for example, and what could be support digital twin? So I don't know who from ERIGrid team would like to answer this question.
Hi, Mohammed. I could say a few words about this.
Yes.
What I think is a very possible way of this evolution is that now that we are in the Corona pandemic, the actual exchange of researchers as part of the transnational access part is limited. So what I see as a great opportunity here is that providing people access to our virtual facilities allows them to get familiar with the tools. Let's say, for example, the Mosaic or the DPSIM tool we have, and then starting to build up their experiments, their scenarios, and bringing them at a later stage to the lab. So to use the virtual access facilities possibly as a way of preparing and getting familiar with the tools of a lab before actually visiting it. That's, I think, my take on that, but maybe somebody else wants to add something.
Yeah, maybe I can also follow up. This is Kai speaking from, I gave the remote access presentation. I think from our lab, we're also looking at the emerging from the other side. So we have prepared educational tools that help actually as a preparatory element for accessing our laboratory. So some tools that have the same interfaces so that you can prepare your experiments directly against the same interfaces. So this is not necessarily something we can directly make available as virtual access, but it's certainly something that a remote access preparation could include. So I think, yes, that's a really good idea that there's some kind of convergence possible, but mind that is really different to have an access that is completely virtualized, can be only in a form of training, and something that is going toward a real lab access. There needs to be some collaboration, and that cannot be purely without registration. And I think that's sort of the transition point where you say, now I need to involve people from the lab. So that's not an automatic transformation that's possible yet with the current organization.
Let me add here also, I think it depends on the type of or the nature of the experiment. So at the end, it could be maybe, but as Kai said, it would probably need also some local support by a local person. Moreover, the European Commission is going more towards this online services. You might be aware the European Open Science Cloud. So that's an initiative that is coming up, and I think we will see in the future much more of these virtual services.
I could add one point here, because the question also touched the area of a digital twin. I briefly showcased the virtual facility of NTNU ICCS, where they have this virtual lab they use mostly in their educational courses, where they basically try to build experiments which are very similar to what they have in the physical lab, which is again could be a good stage for students to prepare before visiting the lab itself. But in my experience, I think it's quite a lot of work to build a digital twin of a full lab. I know that I think DTU is approaching something similar, what Kai mentioned before, that they are trying to build a virtual version of SysLab, so to say. But yeah, that's a lot of work, and I think in many areas we're not there yet to have these fully virtual replicas of a physical lab yet. But I think that would be a nice way to go in general.
Okay, thank you. So going to the next question, can a copy of the contract be sent before applying? And I guess this is regarding regarding the access to the ERIGrid transnational access.
Yes, Mohammed, I can take this one. Yes, the answer is yes. So the contract will be included, or a contract model will be included in a public deliverable of ERIGrid that is going to be published in the coming weeks. Having said that, it's also necessary to emphasize that the contract is something between the host lab and the user group, which means that what is going to be found in this deliverable is just a reference document that of course can be modified, can be changed a little bit, or reinforced with some, let's say, additional clauses by the host lab to cover specific individual conditions of that organization on even country regulations. But in short, the answer is yes.
And just to add, we will add that to the website. So you will find that a corresponding link probably in the physical lab access FAQs that are available at the lab access site.
Okay, so there's more questions coming, but we are running out of time. So I would kindly ask to ERIGrid team to answer the last question, and if you, the speaker, don't mind, I will kindly ask you, the speakers, to answer the rest of the questions, and we will follow up with an email with answered questions and also a link for the presentation and the video recording in case you didn't manage to attend the whole webinar. So, so the ERIGrid, so to the ERIGrid team, is there a specific platform promoted for publishing the project results?
Yes, let me answer this question. At the end, we are linking the project results to the project website. In the previous project, ERIGrid 1, you can find that under the lab access, there's a sub-menu called TA success stories, as well as the selected user projects. So we will do that in the same manner for ERIGrid 2. And the preferred way for ERIGrid 2 is also to upload all the reports, not only on the project website, because the project website will disappear after a couple of years after the end of the project. Our new approach is to upload it to the Zenodo data repository platform, where we have created a community. So the idea is here to share it via Zenodo and link it to the project website. I hope that explains the question.
Okay, thank you, Thomas. So I would kindly ask Graham to take the final words or closing words for this webinar. Graham, we cannot hear you.
You are muted, Graham.
It looks like there's some technical problems with Graham's mic. We cannot. Okay. Okay, so I would like to thank all. I'll take it over and would like to thank all the participants and all the speakers for this interesting webinar. Please keep tuned, and we will update you about the link and the slides with all the information about both project PANTERA project and the ERIGrid project and the virtual access. So we will going to send a dedicated email to all research participants with all the information. Also, I would send a complete answering the questions that we didn't manage to answer today. So sorry that we didn't manage to answer all the questions due to time limitation. And I would like to thank you all, and please feel free to disconnect. Thank you all.
Thank you. Bye-bye.
Thank you.
Thank you. Goodbye.
Bye-bye.
Thank you. Bye-bye.
Bye.
Thank you.